Okay, here's problems 43 and 44, and it's performing the indicated operation. That's what it says here. One thing I want to go over before we begin is that when you have parentheses around groupings like this is basically grouping terms. And there's an addition sign in between here, between the groupings, and there's a subtraction sign between these groupings. Now, when we drop the parentheses, if you watch problems like this worked out, you'll see the parentheses go away and you think, well, why? What happens is, if in front of this set of parentheses is a positive 1, in front of this set of parentheses is a positive 1, in front of this set is a positive 1, in front of this set is a negative 1. And this is why this whole concept is important to understand. When we distribute a positive 1, it doesn't change anything. All of these terms, and when I say terms, I mean the negative 8 is a term, this is a term, 3 to n to the 6th, this is a term, negative 9n to the 4th. When we multiply 1 by each of these terms, we just get back the terms. Nothing changes. Positive times negative is negative. Positive times positive is positive. And to the 6th, positive 1 times negative 9 is still negative 9. And to the 4th. It doesn't change, but oh, aren't we clever? We just dropped the parentheses. They're gone now because we distributed a 1 on that's always outside of any parentheses. In this case, it's the same thing. So you would distribute a positive 1 and get back 1 times, you get plus 6n to the 6th. And you're like, why is she doing this? You're going to see why over here. It's going to make a big difference. And then we distribute 1 times the 3 plus, so that's a plus 3n to the 4th because positive 1 times the positive 3n to the 4th is still the same. Positive 1 times negative 2 is still negative 2. Okay, now I've dropped all the parentheses. It's like magic. Anyway, and you can only do that when there's this addition in between, or it only makes sense to do that when there's addition in between the groupings. Now, next step here, let's complete this problem 43. We're going to identify the like terms that we can combine. So this term has an n to the 6th, so I look for another term with n to the 6th. That is not this term, but it is this term. Oh, and let's include that positive sign along with it. Okay, so now I look for values that, I guess I skipped over the 8, but let's look for other numbers that are all by themselves. That's not by itself, that's not by itself, but this is, so we can combine those. Now let's look for the terms now left both have n to the 4th power, and those can be combined. So let's do that. Let's combine these terms that are like terms. So I'm going to take the negative 8 and I'm going to combine it with negative 2. So bring the negative 2 over. Then I'm going to take the positive 3n to the 6th, and I'm going to add it to the 6n to the 6th. I'm just putting them together, near each other rather. I'm putting them near each other so we can complete the problem. And then the negative, I take that negative along with me, negative 9n to the 4th, and I take the positive along with me, and that's positive 3n to the 4th. So you can see the terms in black are here, the terms in blue are here, and the terms in green are here. They're still all strung together, so let's add it all. Negative 8 minus 2, and I want to show you something really quick, making sure that you always enter this correctly on a calculator. Make sure you say 8 negative, so you see the negative 8 there, and then minus 2, and that will equal a negative 10. Okay, so then we have a negative 10. So I solved that. I'm just going to go and solve each of these groups. These are like terms, so I just add the coefficients. Coefficients are the numbers in front of the letters. So 3 plus 6 is 9, so that's plus 9. And that doesn't go away. End of the 6 is still there. And then this over here is negative 9 plus 3, which is a minus 6 n to the 4th. And if we use our calculator on that one, it would be negative, whoops, clear, 9 negative, if that's how your calculator works, but make sure it's a negative 9. And then you will do plus 3, negative 6. So this is your completed or simplified equation. All you did, it used to be a lot of terms. Now we've whittled it down just to 3 terms. So that's why it's called simplifying. It went from 6 terms to 3 terms. And it's as small as it can be. So let's look over here. We're going to do the same thing. We're going to distribute a 1. This is a positive 1, so nothing changes because we want to get rid of the parentheses. So 1 times 5n to the 5th is that. 1 times negative 8 is still negative 8 n to the 3rd. And then 1 times the 17 is still a positive 17. Now we're going to keep going, but this is a negative 1, and here's where things go different. Negative 1 times the positive 7 is a negative 7 n to the 3. Negative 1 times the positive 2, now it becomes negative 2 n to the 5th. Negative 1 times, sorry, I didn't put that arrow there. Negative 1 times positive 3 then becomes negative 13. Sorry, negative 1 times the positive 13. Okay, that's why this makes a difference. You are distributing a 1, positive here, and then negative here, when you are dropping the parentheses. Okay, now let's put together our like terms. Our numbers are green. Let's see, find numbers. This is number and this is a number. And let's use blue for n to the 5th. And I always circle the sign that's next to the number so that when I move it, I move the sign along with it. And then last are n to the 3 terms, the terms that are alike. Okay, so let's write it out as 5 n to the 5th. And I'm going to combine that with this one, so I put the minus 2 n to the 5th. And then I'm going to take this negative 8 n to the 3rd, because that negative is coming along with me. And this is a negative 7 minus 7 n to the 3rd. And then this is a plus 17 and a minus 13. So I just cleaned up the problem a little bit so it's easier to see. The blues and the green, no, the blacks. Okay, so we're going to just combine those terms. So we're down to 3 terms again. 5 minus 2 is 3 n to the 5th. Negative 8 minus 7, so let's take a look at that in the calculator. 8 negative minus 7 equals negative 15. So that is minus 15 n to the third. And then plus 17 minus 13 is 4. That's a plus 4. Okay, so our final answer then for 44 is that our expression is simplified. We're not calling it an equation because it's not set equal to any value. It's just a string of terms. Okay, that's it.